Chapter 5, Lesson 6, Writing Parallel and Perpendicular Lines. Alright, now first of all, you need to think about what is a parallel line. Because in example 1 it says you want to have a parallel line that runs through a given point. So if you're looking on a graph, and let's say that's your x and y, and you have one line that goes this way, you're going to be finding a line that goes that way. Those are parallel. So it's important that you have a visual before we do this. Alright, so we want to find the slope-intercept form for an equation for a line that passes through negative 4, 1. So here's my coordinate, x, y, and is parallel to the graph of y equals x plus 3. Now, if it's parallel to y equals x plus 3, then it means it must have a slope of what? Well, the slope must be the same. So the slope must be 1. Alright, so here, as we've done before, what is the x value for coordinate 1? The x value for coordinate 1 is negative 4. So we put in negative 4 here. On the left-hand side, I have y minus, what's the y value? 1. Alright, so we've done our substitution. Now we want to simplify. On the left-hand side, nothing to do yet. On the right-hand side, well, I have a double negative scenario. What's the opposite of subtracting? Well, that becomes adding inside. And then we're going to do distributive property. So that's just x plus 4. So we've simplified a little bit. We've done the distributive property. Now, I want to end up in y equals mx plus b. Well, I have the y over here. That's good. That's where I want it. But I need to get the 1 to the other side. Additive inverse. So I add 1, I add 1. Cancel it out. I get y equals x plus 5. I'm in the correct order now. So there is your equation for the line that is parallel. It is in the point of y equals x plus 5. All right. Moving on to example 2. Now we need to determine whether lines are perpendicular. Now, we have two equations. We have y equals negative 2/3 x plus 1, and we have y equals 3/2 x minus 2. Well, the slope of the first one is negative 2/3. The slope of the second one is 3/2. The rule here is, if lines are to be perpendicular, they have to, when you multiply them, be negative 1. So I have negative 2/3 multiplied by 3/2. Using what we know about multiplying fractions, 3 divided by 3 is 1. 2 divided by 2 is 1. 1 negative times positive is negative. In the end, I get negative 1. Remember, if the product of the slopes is negative 1, then the slopes are perpendicular. So in other words, these two lines, whichever way they are on the graph, they come together at 90 degrees. Situation number 3. I want to find a perpendicular line through a given point. Now I'm going to use the one from the book just because it's neater and we can follow along. So I want to find and write the slope-intercept form right here. Slope-intercept form of an equation of a line that passes through this coordinate, there's x, there's y, and is perpendicular to the graph of that. Now, I'm going to have to do some manipulation here. So, they give it to you in standard form right here. But I need to change it into y equals mx plus b. So, I'm going to manipulate it. I write the original equation. Then what I do is I subtract 9x from both sides. That way I'm getting x on the right-hand side. At this point, now I simplify. Now that I have x over on the right-hand side, now I want to divide by -6. You know the -6 cancels out. On the right-hand side, you got to be careful. I have 9 divided by 6. I get 3/2. I also get 3 divided by 6, which gives you the 1/2. So now I have a basic equation to start with. It's important because I need that slope. The slope is now 3/2. Knowing the slope and knowing what you know about perpendicular lines, you can take the 3/2. You can invert it, make the reciprocal, make it to -2/3. That's going to be your new slope. So you did all of that work just to find the new slope. Now that you know your new slope, you can take it and substitute it in to your point slope form. And this will eventually find the equation for you. You put in the slope into the point slope form. Then you take the coordinate all the way from the beginning and you put it in. And when you substitute that in, here's your x value. You substitute it in for x. You take your y value, and you take the y value and substitute it in for y. When you do that, we now simplify. Nothing to do on the left-hand side. On the right-hand side, we've got the distributive property. So we end up with -2/3 x plus a -2. Now, we want to add 4 to each side. That cancels out. We have 4 minus 2. We end up with +2. So here is your final statement. Now, this is tough. It takes you a couple times to get through it. If you need help, please make sure to see